In this Revit tutorial, I'm going to show you how to create a parametric brick pier to go on the corner of this external wall. Now, this tutorial came about via a question posted on the BIMscape forums, where one of our members had this scenario where they had an external wall and the detail they wanted was for the outer leaf, i.e. the brick leaf, to protrude past and form a pier or a buttress, if you like. So to stand proud of the wall by about 100 mil to form this solid sort of pilaster, if you like, on the corner. Now, they'd had a go at trying to form this detail in Revit and come to a sort of dead end. It wasn't working out. Now, they've posted a couple of screenshots of what they attempted, and I'm going to show you those in a second, just to show you how far they got to, and we'll describe some of the problems and why it didn't work out. Then I will describe my thought process as to possible solutions to achieve what they wanted, and then finally we'll go into the meat of the video, which is the tutorial on producing the parametric pilaster family. So let's switch to the screenshots of their attempts to sort of resolve it. Here is the first screenshot that they posted, so you can clearly see the external envelope, and they want these brick features, pilasters, however you want to term it, on the corners. Now, they'd formed different wall types here. They played around with the wrapping of the layers to try and get this to work out, but you can see as the wall protruded forward, it sort of distorted the cavities. This no longer works. This leaf sort of steps back here, and it's clearly not what they're after. So that was the first screenshot. Then they tried a different solution, a different strategy, and that resulted in this next screenshot. So with this one, it looks, I think, a little bit better than the last one, but it's clearly not correct there. This layer, the inner leaf, doesn't wrap round. Sort of looks like the plaster line comes through and the cavities don't join. So it just didn't work out, and I asked if I could take a look at it and make any suggestions. So that's when I fired up Revit, and I'll just switch back to it now. Started a new project and just put in a couple of external walls just to mimic that corner. So we've got a brick outer leaf, a cavity, and a block inner leaf, and a plaster layer. So we want to form this brick protrusion at the front here. Now we want it the same width as the main wall, which I think is about 277 millimeters. We want it in solid brick, so the same material as this outer layer, and we want it to stand proud of the wall by about 100 mil. So the depth from the front of it back to the main wall is 100 mil. So then I started looking at different solutions, because I just thought it would be interesting to see what different strategies in Revit would achieve the same thing, because quite often in Revit there are different ways of coming to the same outcome, but each with their own pros and cons. So I myself played around with creating a different wall type, and I played around with the priorities of the layers. So if I just click into there, just to show you what I mean, if I edit the type, we go into the structure of this wall. You may be familiar with the first column there, the function layer, which basically, if you look in the square brackets, the numbers there are the priorities. So that determines, when you have two different wall types, how the different layers interface. So the challenge here was to create a wall type just for the pier of a brick material, which only interfaced with the outer layer here. We didn't want anything to interfere with the cavities. Now the problem is, in any wall type in Revit, the minimum you need in terms of layers is just one layer, but that has to reside in the core zone. Now the core zone typically is in the middle of the wall. So when we create our new wall type for the pier and we put our brick layer in, it has to be in the core zone, So again, it started to want to interface more in the middle of the wall. We just wanted it to butt onto the outside there. So I played around with that to sort of different success really, but it seemed an overly complicated and convoluted and slightly hit and miss process. I then considered architectural columns. Now a property of an architectural column as opposed to a structural column is that they will embed automatically into walls, but again you can see it, although we had a solid monolithic column, it distorts the structure of the wall and brings the cavity round. We just wanted this to go through, albeit that wasn't on the corner, but it'd be the same effect. So again, not ideal. So I then thought, well, how else could we achieve this? I thought about possibly using a vertical wall sweep. So under walls we've got sweep, and you can use those in the vertical orientation. So we could apply that. Now I could move that over to the corner, but again you can see the problem here. The hatch pattern goes the wrong way. Now yes, we could duplicate the brick pattern, make it a second version of it and turn it through 90 degrees, but again it just starts to get really convoluted for what should be quite a simple strategy or solution. So I dismissed that one, and it brought me to the fact of why not we just simply create a parametric pier as a family, a component family that we can just host onto the wall. We can type in the dimensions we want for it and the height, and we can reuse it. So that's where I arrived in terms of a strategy, which is what I'm now going to show you how to do. So if I go back to a plan view, so it's going to be a family, so we're going to play around in the family editor. If you're interested in a bit more information about creating your own families in Revit, we do have different articles, tutorials on the website, and a full course on creating Revit families. So we've got a file, new family. Now one of the main things when you create a family in Revit is choosing the correct template for the job. So we're going to go with a metric generic model. Now we're going to make it wall based so that it automatically snaps to the wall or is hosted on the wall. So that's the template I'm going to choose. Hit open. The family editor opens. The interface changes for all the family editing and creation tools. So we've got a sample piece of wall, and that's because we chose a wall based template. Tells us which side is the placement side, so this will be where we'll create our pier. So before we do, we're going to just set up a simple framework in which we can host the sketch lines for the extrusion. So I'm going to create reference plane. I'm going to do this fairly quickly. You can watch this video obviously again a few times if you want to sort of follow along with what I'm doing, but I'm basically just setting up a framework, if you like, a skeleton of the footprint of our pier, and I'm doing that in reference planes. Now we could just create this pier as a fixed size, fixed dimensions. The person asking the question presumably had an idea in terms of its width and depth, but if my logic is, if we go into the trouble of making a component family, we might as well spend a couple of minutes extra and make it parametric so that we can reuse this family in different projects or in the same project with different sizes, all for the sake of just adding a couple of parameters. So I'm going to dimension this now. Put a line dimension there. I'm going to make those equal. So the purpose of this dimension I've just put in is to make sure that when one of these reference planes moves, the other one doesn't. They always stay equal around the center point of this central reference plane. So I'm now going to put an overall align dimension, which is the one I'll use to control that width. So we select that. Now if we look up on the menu, label, i.e. the parameter or the property, there's none at the moment. I'm going to create one. Going to call that width. I'm going to make it an instance parameter so that we can change it for each pier if we need to. They can be different in the same project. So it's going to be length, that's fine, it's picked up all that. I won't complicate this tutorial with shared parameters. If I was doing this for real for myself, I would use shared parameters so that we can extract this parametric information into a series of tags or schedules within the project. But for now, for simplicity, I'm going to leave them as family parameters, so they will just be available in the properties for that family when it's selected. So hit OK. So the label appears there with the current value, width 840. We are going to now create another align dimension. Now it's crucial that we dimension to the reference plane. There is a reference plane that came in with the family template on the face of the wall. Now the purpose of that is, obviously, when you're using this family in your own projects, this wall could be any thickness. We've just got a piece of sample wall of a set thickness that came in with this template, but there's nothing to say that the wall you're going to use this component on might be twice the thickness. So in order that your component doesn't end up sort of buried in the wall because it's based on a finite thickness of wall, it has this reference plane that represents the leading edge or the front face of the wall. So we need to make sure we dimension to that reference plane. So if I use a tab key, I've got that now, you can see it's highlighted. Select that there. Select the front reference plane. We need to convert that to a label. Need to create a label. I'm going to call that depth. It's going to be an instance parameter again. Hit OK. So we've got two parameters now that when we use or load this component into a project, we can vary those, and you're used to the properties palette. So when you select a door, window, for example, you've seen all the key sort of dimensions. Well, that's what will happen here. Now we've set these up, these will appear when we select the object, and we can just type in the values there in the project that we want our pier to be. So the final thing we're going to do before we actually create the geometry is create another reference plane and a dimension to represent the height of it. So again, we can vary the height we want this column or pier to go up to when it's placed against a wall. So I'm now going to look from an elevation view. I'm going to create a reference plane. This is going to represent the top of the column or the pier. So I am now going to form a third align dimension from the reference plane. That's always going to represent the base of the column up to the top one there. Again, select the dimension we've just created. I need to create a new parameter for it. I'm going to call that height. And this certainly does need to be an instance parameter, because we might have these different piers around our building in the same project, and some might need to, for example, reach up 2 stories, some might be single story, etc. So that's the only way we're going to be able to vary between the same component, is making them an instance parameter rather than a type one. Hit OK. Right, so we've got a framework all set up. We're now going to just create the geometry. So create, it's going to be a simple extrusion. Goes into sketch mode. I can use a rectangle tool. All I'm doing is defining the footprint for our extrusion in these pink lines. Now the crucial part here is to make sure that each of these 4 lines is locked to the reference planes. And the reason you're going to do that is because when you use this component in a project and you go and vary those parameters that we just set, this depth and this width, what will happen is you'll put different values in there, which will force Revit to make these reference planes go closer together or wider apart as the dimension changes, and you want these sketch lines for the extrusion to stick to them. That's why we're putting these constraints on. Otherwise, what would happen is the reference planes would move apart when you change the dimensions, but there would be no change to the position of where these sketch lines are. Basically, the extrusion would just stay the same size because it has no reason to change shape. We've locked it and said when these move, these sketch lines follow it. So that's what the constraints are for. So we've done that there. Okay, that forms extrusion. We can't really see it because we're looking in plan. So let's look from the placement side. There's the extrusion. It's quite short at the moment. So if we drag that up and again constrain it to the horizontal reference plane we created. So again, in your project, you can see how this is going to work now. You'll load this component in. You'll want to change the height. You'll select the component. This height parameter will be listed over in your properties palette. You'll put a different value in, which will cause Revit to raise or lower this reference plane. And now, because we locked or constrained the top of the extrusion to that reference plane, then the extrusion will rise or fall accordingly. So basically the pier gets taller or shorter. So far so good. Let's just have a quick look in 3D. And there's our pier. We don't need to worry about the dimensions now because we made it parametric. We can just set those once we load it into the project. The final thing we need to do before we start using it is actually just set a material to it, because we want that brick material on our pier so that it matches in with the brick walls we're going to use it with. So we can simply select the geometry that we've created, the extrusion. Material, it's not set at the moment, it's just by category. So I'm going to click on that, hit the button with the three little dots to bring up the materials browser. You can see a very limited palette of materials that come in with this template. So what we need to do is create a new material, and as long as we name it the same as the material that we want to match in the project, Revit will handle that. We don't have to create the material in its entirety in the family editor now, i.e. with all the hatch patterns and the graphics and the colors. We just create a blank material, but as long as it has the same name, so in this case the one we're after is called Brick Common, then when we load the component into a project that has that material in, it will cross-reference it and apply that material to our component. So I'm going to rename this Brick Common. Okay, that. Right, we're ready to try this out. So if I load into project 2. Okay, and there it is. Now again, if we were doing this for real, we would save this obviously somewhere safe, and we give it a proper descriptive name. We might even set up some standard types for different sizes, standard sizes, but for the purpose of this tutorial, we just want to show you the principles of how we create this and then use it. So it is wall based because that's the template we chose. So you can see we get the no entry sign unless we go near a wall, and there we have it. Click on there and it places it. Now let's select the component. There are our parameters that we set, our instance parameters. So we wanted, I think it was 100 by, let's say 440, something like that. Now we can just use the move tool to bring that over. Stick it on the corner. Let's take a look in 3D. There we are. Now the final thing, just to tidy up so it's more integral with the wall, both in elevation, because you can see we've got a line down there, and certainly in plan you'll have noticed that line. We just simply use the join geometry tool, select that, select the other wall, and there is our completed pier. Just check this out again in 3D, and we have a pier or a column at the corner, all displayed correctly and in plan. Now one final thing just before I finish, if you followed along and your hatch pattern has not come out as neat as that, it's probably because that particular drafting hatch pattern is set to be aligned to the elements rather than the view. So I will change it back to that and then show you how to adjust it. So if I select the wall, and what we need to do is just drill down and find that material. So I'm just going to go into the structure. It's the brick common there. Select it. Now it's actually the hatch pattern where it's cut that's causing a problem. It's this one here. Pattern's called brickwork. So this is an attribute within the overall material. So I click on brickwork. There's the brickwork drafting hatch pattern. If I edit that, now right down here at the bottom, so you can see how far we've had to drill down to find this, there is a parameter there called orientation in host layers. So it's orientated to the view at the moment. If I put a line with element, which is the default normally, so that could be why you're seeing it not as neat as this example. Let's just go in all the way back, apply that. You may be seeing something like that. So what's basically happening now is for each individual element, i.e. that piece of wall, then this piece of wall, and now the pier, it's aligning or starting the alignment afresh each time with the pattern on each individual element. So there's no uniform, if you like, synchronization of the pattern across elements. Each element, if you like, is treated in isolation in terms of how Revit is putting the pattern on. You can see there it neatly finishes, or not neatly as the case may be, and the same there. What you want to do, I would suggest to get a much more satisfying result with your hatch pattern, is you just want the pattern across the whole view, so it runs across the elements. So for those of you sort of old enough to remember sort of pen and ink drafting, you'd sort of get your set square and you'd put your lines across there like that. So that's what you want to reproduce in Revit. So let's just go and find that material again. So edit type. I could just go to the materials browser. I'm just using this method of drilling down to get to it. So brick common, hit the three buttons. There it is, brickwork pattern. Click on that. There it's highlighted. Edit it. Right down at the bottom, align with element. So we've seen that that's not really particularly successful. Swap it to orient to view, so it just takes the view as a whole and applies it across all the layers. It's okay, and okay again, and one more, and in fact one more, and we're back out, and it's changed the drafting hatch pattern, and that looks a lot neater. And because we made our parameters for our family as instance parameters, we can now go and put any number of the same family but with different sizes and different dimensions, because they were instance parameters rather than type parameters. Just gives us an extra degree of flexibility. So hopefully this has been of interest and of use to you, and it should be hopefully a good example of why it's a good idea to start experimenting with the family editor environment in Revit, because there will always be things like this. Could be to do with walls, roofs, 101 things where you want some specific detail and the out-of-the-box tools don't quite work, or they're too convoluted, maybe you can't find any ready-made components that easily. So with a few simple concepts under your belt in a family editor, you can quickly produce these parametric components that sort the short-term requirement, but also can be reused in future projects.